Calculating the size of the final payment on a loan that is to be paid incrementally throughout the year is a practical skill in finance that requires understanding of simple interest and future values. This knowledge is crucial for effective budgeting and financial planning. Let's take a look at a scenario where this would be necessary. A $5,000 loan advanced on April 1st at a 6.5% interest rate requires payments of $1,800 on each of June 1st, August 1st, and the final payment on October 1st. What must the final payment be to satisfy the loan in full? To answer a question like this effectively, it's important to create a timeline of these values. So the loan was advanced on April 1st, and it was for $5,000. On June 1st, $1,800 must be paid off. On August 1st, the same applies. And there's one more payment on October 1st. We'll say that this is October 1st, which is unknown. We'll call it X. Now, relative to April 1st, these payments, namely this one, and that one, are happening in the future. And so what we have to do is discount this payment back to April 1st, this one back to April 1st, and that last one, and their sum should add up to $5,000. Remember that payments made in the future are valued higher due to the time value of money, which is why they must be discounted back to their present value to accurately reflect their worth in today's terms. So let's write that down algebraically. We know that the present value of the June 1st payment plus the present value of the August 1st and October 1st should all sum to $5,000. Now, how do we write down the present value of a future value of $1,800? Well, I have these two formulas here, and notice that the simple interest including principal formula encompasses the principal plus the interest earned. Another way to understand this formula is that rather than using A, which is what's typically used in literature, we can say that the future value is equal to the present value multiplied to 1 plus RT. And so if we look at June 1st in isolation, for instance, its payment amount is $1,800, and that occurs in the future relative to April 1st. And the present value is what's unknown to us. We want to discount that back to April 1st. So PV is unknown. We have 1 plus R, which is the interest rate. The interest rate is 6.5% annually, so 0.065. And the time from April 1st to June 1st is a span of 61 days. Take a look at the chart and you'll see that April 1st is the 91st day and June 1st is the 152nd day of the year. If we take their difference, we get 61. And we'll represent that as 61 out of 365 days in a year to represent the value of T, which is the duration. Solving for PV, we get 1,800 divided by whatever that is equal to. And if you use your calculator correctly, you'll end up with the present value of that first payment. So here's how it's done. 1,800 divided by 1 plus 0.065 multiplied to 61 over 365. And we end up with 1,780.656702. You want to write up to 6 decimal places if necessary. And so we'll write the entire number down. So that represents the future value of June 1st. And we have to repeat this 2 more times for August 1st and October 1st. We can actually reuse this equation, and all we really have to do for August 1st is change 61 to reflect the number of days that pass from April 1st to August 1st. And it happens to be 122 days. Let's repeat this calculation, but with that change. On our calculator, we'll change it to 122 days, and we end up with another present value that's roughly close to the other one, being 1,761.72472. Now to discount the October payment, which is unknown to us, what we'll change is the 1,800 and be replaced with X. And of course, the time elapsed from April 1st to October 1st. Those two dates happen to be 183 days apart. As you can now see in the equation underneath, this is impossible to evaluate because x is unknown to us. So we'll just place that expression into our equation. Let me just make some more room. And now we have an equation where if we solve for x, we find that unknown payment that will satisfy the loan in full. To solve for x is simple. We bring that value over to this side and that value over. Let's see what happens. So 5,000 take away 1780.656702 take away 1761.72472, and that gives us 1457.618578. And that's equal to that expression. And from here, to solve for x, we multiply both sides by whatever the denominator is equal to. So simply take the value on your screen and multiply it to 1 plus 0.065 times 183 over 365, and we get our value of x being $1,505.12. And make sure that it is at this stage where you round to two decimal places. So our last payment, x, is 1505.12. I hope you found this tutorial helpful. If you have any further questions, leave it in the comment section and I'll gladly help you out. Thank you for watching.